Alright, whatever you do, do not move the microphone. Yeah, do it. Alright, so here we are back with the desktop. You'll see that the folder from yesterday has a lot more crap in it, and that was me testing a lot of stuff. I had a lot of fun. First, we're going to talk about this little tool I made. I'll share it in the tools section. And right now, it's strictly only for bitmaps. Gonna go over the tool I made and then Filmora. So, hey Alex, what's up? Check this out. You're gonna want to see this. It's gonna be fun. So I finally wrote some code. It's this long. So we have encode, and this is it, and then we have decode, and that's it, and then this is to run it. Let me just show you what it does. So let's go and put city.bmp on the desktop. And I need something to hide. Let's grab the good old FJLJ crackme4.exe. I'll put that on the desktop. I really need to fix my fences. I've cracked it in the VM, and I haven't applied it here ever. So, Mr. Alex, are you ready? So, this is a picture of a lovely Chinese, maybe Japanese dirty knees. Look at these city block. Who knows? Maybe it's Thailand. If I lose audio, it's because I need a new XLR cable. This one is about to fall apart, and if I bump it, off. Alright, so, lovely picture. I don't know if he's in here, haven't looked at it at all yet. Winky face. No, I haven't, except the screenshots. I like to have so when I'm looking at a program, I like to have a fresh look at it. You know, when I'm with you guys sharing it. Now, when I'm programming and debugging and hacking my way through this, that, and the other thing, it gets real boring real quick. This one was fun. Now, back to what it does. So we've got the FJLG crackme, we've got city. Let's do a CLS, and let's go Ruby F embed. You'll see that I wrote this beautiful usage. I think it's beautiful. It works. So it says usage, fembed, task, files, options. Task, encode, decode. Okay, fair enough. You can put in encode or decode. Files. For encode, you do an input image, an input file, and output image. For decode, you do an input image and output file. Your options, only encode has options. And that's bits per byte to use. Bits per byte to use, 1 through 8. And your byte spacing, 1 through 255. We've made some changes, and this is real fun. This could be expanded, but I don't want to. Like, it's good enough. You'll see. And then example, encode, fembed encode picture.bmp secret hidden 2.3. Great, sure, why not? Decode, fembed decode hidden.bmp found.txt. All right. So from here, let's go ahead and do Ruby, fembed, and I was playing around, of course, because, I mean, what do you do when you get a new toy? You play with it. Encode, and let's do, oh, my back is sticking to the leather, city.bmp, FJLJ, crackme, does tab work in here? Yes, it does. 4.exe, and do city h.bmp, and let's go with something pretty modest. We'll go with 1 and byte spacing, I don't know, let's go with like 6. It will tell you space available 244 kilobytes, space needed 80 kilobytes, complete, and it spits out our file named city.h.bmp. Let me minimize this. Let me drag it over here, and we'll deal with the warning message again. Maybe I should just buy it since since now I've stated that it's expired and I've cracked it, I think I'm obligated to buy it. I think I have to. Otherwise, I'm a shit person. Anyway, so now let's open city H. So this is city H. I'm going to delete these other two cities. I wish I would have put these in a folder, but I didn't. So here's city H, and here's city. City, city H, city, city H. Can you spot a difference at all? Let's zoom in here, city H. See anything? Now, you might think, oh, that looks a little shit, but let's go to city. There's city, let's zoom in. Oh, it's shit in the original. Got it. So, city, city H, city, city H. Now, great. Sure, we did something. So, city H is right here. And let's move this up a little bit here. And let's do decode. Decode. City H dot BMP. And let's put that in work.exe. Worked. Maybe .exe. It says complete. And then if we minimize, we should see worked maybe.exe. But the trick is, does it actually run? Let's run it. Hey, please register to continue. FJLJ, some numbers. Wrong. Okay. So that runs. So we just extracted this executable from this picture. But did you see it in there? And look, the file sizes are exactly the same. 1.42 megabytes. 1.42 megabytes. Now, this is where it gets fun. Say we go, we want to do 1, and we want to space them 255. It's going to say, well, your file needs to be 5 kilobytes, not 80 kilobytes. Now, you might be thinking, wait, it's not kilobytes. It's only 10 kilobytes, not 80. Well, 1 bit per byte is 8 times. So there you go, 8 times. Because we're only doing 1 bit per byte, the least significant bit. So we can't do 255. What happens if you do 256? Invalid byte spacing, idiot. 255. Can we do 0? No, you can't. Okay, so let's start making it smaller. We know we need a lot more than that. Let's try half 128. Nope. Sorry, bud. Let's do 64. Nope. Let's do 32. Getting closer. So, instead of lowering this number, because likely we're going to land something on like 16, 17, 18. 18 is going to be it. It's the lucky number, 18. My pocket is blowing up. Okay, so 18. Now what does it look like? Here's city H. Well, now we've optimized it to put them as far apart as possible while only using 1 bit per byte. So there's no way in hell you'd ever spot that. So we'll close that. Now, this is where the fun starts. Let's use all 8 bits of the pixel byte that we use. Let's use all 8 bits of it. So now we need 10 kilobytes. We've got 80. Great. Now this you'll probably be able to spot. Yeah, it's kind of fuzzy down here. But what if we space those out? Because we got lots of room to space it out. So let's go 180. Close. 175. 155. Almost. 150. 145. Now, of course, yes, we could optimize this to do it itself, but then you don't have the control over it, and it's really fun to play with. Let's see here. Does this one work? Oh, look at that, 146, and it's almost a dead perfect match. So now if we look at this, yes, you'll see it, but look how cool this is. Because if you think about what we're looking at, look at the spacing. It is so perfect. And if you think about what we're looking at, we are looking at each byte of our code in graphic format. Now, is this useful? Well, no, not really. For hiding it, it's not useful. But if you think, well, if I put a black background in there, jumps always turn this color. Then you could have a visual representation of your executable. So if you're looking for like data and things always are this color and this is always this color, it might prove to be helpful. I haven't played with it yet, but this is fun. So now instead of 8, let's do 7. Of course, now we're not going to have enough space. But look, we don't have to make up that much. Hey, that was a good first guess. Let's try 7, 8. Oh, dang, that is close. So 129, yeah, 128. So that's like dead on the money. Now, if we close this and reopen it, you'll notice that they're still there. The ones in the middle and the bright spots aren't very noticeable because they're all dimming just a little bit. Because now we're only using 7 bits. We're leaving the most significant bit. So whatever color it was before, it's still mostly that first bit is there. Does it work on PNG, JPEG, JPG? No, you missed the intro where I said it's only for bitmaps currently. Because bitmaps, you can get a lot of information in a pretty big file, pretty big image. PNG, JPEG, JPG. So this is the code right now. And next up, I want to do JPEG. There's not as much space to hide things without causing some disruption, but there is. I mean, there is space. You just won't get this type of optimization. For example, if we start going down to 6, and now we can go up to 180-ish. Nope, 160. Oh, right, we have to go bigger. Derp. 100. 110. Oh, damn. 09. Damn near dead on the money. Wait. Yeah. So 109. Now, you'll notice they've faded yet again. And what we're doing is we're stretching all those out. If I put it to 1, it would just be... So yeah, like they're fading again even more. Because we're only doing 6 least significant bits. So now let's do 5. And let's space it, I don't know, 88. Oh dang, I'm good. Let's do 89. 91. 92. Oh, 91 it is. So, and it should, oh, come on, there we go. There you go. So now it's reloaded. You'll see now they've faded once more. Hi. Howdy. So if we zoom on in, you'll see now just some of them, like the lines where they're going across, because that's the spacing. Now we could do instead of a linear spacing, have it do a modular spacing or a random spacing. Now random wouldn't work because you wouldn't be able to decode random. You have to be able to find it. Now you could chain it. You could do like Fibonacci sequence of it and chain them. You could decode that. Anything you can do forward, you can do backwards. So this, yeah, we can see the lines, but when we zoom out, really, it's only the darkest areas that we're seeing anything, and that's because we're increasing the reds and greens. So now, watch what happens when we go to 4. And it should take less and less as we go. 2. I knew I was going to skip it. Okay, so there we go. And let's go ahead and run this guy here. And look, can you notice him at all? I mean, if we look real close in some of the dark spots, maybe the lightest spots in the sky. There you go. Lightest spots in the sky, we can see some of them. But even that's pretty good. And we can, again, just to, make sure that these are all still working at all these different variables, we can decode city H to worked maybe 1. Complete. And it knows where to look, what to find, and goes through it. The less of bits used, the bigger the size. Kind of. So less bits used, the bigger the size, but you can shrink your spacing or grow your spacing as well. So it's an optimization. You can go, if you have shorter spacing, you can use less bits. If you have higher spacing, you can use more bits. And somewhere right in the middle, like right now, we've found that we're using half the bits in the entire byte, and as long as we space them 73 apart, they're pretty damn not noticeable. And my crack me still runs. Like that. Do you see anything different between that and that? That and that. Maybe a few just dots here and there, but if you saw this on the web, no. You'd look at it and be like, I don't see anything. Now, when we go any lower, I did this quite a long ago. Awesome. I'm glad. I mean, I did as well long ago, but I wanted to revisit it. And I've had a lot of fun because I wrote it in such a manner that you can hide anything in a bitmap. And if you spend time, you can optimize it to fit larger things in there. For example, I can get probably a 2 megabyte RAR file on a 5 megabyte bitmap. I bet I could do that. But yeah, so here's the encode. Like, some people are just joining, you probably think, oh, this guy's just using some tool that hides stuff. Well, no, we made the tool. Now, this is in Ruby. Now, shots fired, sure, do it. Welcome aboard if you just joined the Discord. Hey, that rhymes. How higher is the size of the output compared to the sum of both files? Size of the output, the output file does not change size. So, city WMP 1.42 megabytes. The output file 1.42 megabytes. We do not affect the original file size at all. We're putting it in the existing bits. So, yeah, we're not like zipping them together. No, we're modifying the pixels to contain our data. And the way that we're doing that is saying, do we want to use 1 through 8 bits of each pixel byte? How far apart do we want to space these pixel bytes? And when is it optimized? Because yeah, you can shove a whole thing in there. You could use every bit of every byte and shove it all in there, but the picture would be gone. I'll give you an example of this. We will need a smaller bitmap because this one's huge. So this crack me is, I think, 10 kilobytes. Yes, we knew this. Let's find a bitmap. That's 900. That's a JPEG. Yeah, let's use this here. I didn't want to do that, but let's open this in edit, and then let's resize it. We'll shrink it by 80%. Save it as a bitmap on the desktop. SFI, sure. Now let's see, how big is that? So that is 351 kilobytes. That's fucking huge. Let me shove that in there all day. Let's shrink it by half. File, save as, SFI, replace. Okay, so original file. Wait, what? There we go. 87 So this file, right? Yeah, you affect the quality, but like for example, our original example of this, if I do 1 and space them as far as possible, probably somewhere around this. Nope, 12, 23, 22, 20, 19, 17, 18. So we're doing the least significant bit and spacing them as far as possible. Now, again, we couldn't tell the difference between the original city, but now this one, here's city H, here's city H, here's city H. Now, if we zoom in on the sky, I don't see anything, do you? Nada. Check over here in the dark spots. Nothing at all, because we're only changing the very last digit. Whether, the difference between a 254 and a 255, that color difference is damn near nothing. That's all we're doing, and we're only doing it every 18 bytes. So there's no way you could ever spot it. But it took us 8 times the size of our file to do it. So it's an optimization problem here. Hey, Soda XP, how you doing? So back to our other example, and that is so now we have a crack.me that is 10 kilobytes, right? And sfi.bmp, which is 87 kilobytes. Let's do encode sfi.h, and this is definitely not going to fit. Space available, nada. So spacing 1. There you go. So we can barely fit it in there. Now, only changing the least significant bit, and we're using, only the least significant bit of every single pixel. You'll see that we can't tell because it's tiny, but there is a red dot there. And if we go to SFI, come on, let me open these side by side. Can I zoom these individually? H. Okay, so we had to go down to 1 and 1, and we're changing only the least significant bit, but we fit that entire exe in here. Yours is advanced, I think, but I actually hit a compressed archive into a JPEG just using command and the size cumulative. Right, yeah, so you can just grab a JPEG and do plus this, output that, but that's just appending it to the end of the file. It's not hidden. You can see it. Like, if we go into the hex of these files, HXD, this is a bitmap. Nobody could ever find that executable in there if they wanted to, especially since you can change where your bytes stop and start, how many bits you use of each byte. If you know how it works, then yeah, but good luck. And if we compare this with the original, you'll see that this changes here, that changes there, and then from there, it's so few, like, okay, 60 CO, let's go to CO. So you see how many bytes are actually changing, and they're changing by 1. And that is encoding our file into this bitmap. So, yeah. Now, if we go and look at SFH and SFI, now H is ours and I is that. Now you see every single byte is changing, if it needs to, by 1. All of this is changing. Let's go down to 300. Everything changes, but it's still a picture, and you can't even tell that it's different. You can't tell that it's a different picture at all. There's this one. That's SFI. That's the original. and this is the one that has our executable in it. Now, if we wanted to do 8, we can space these out a little, but let's not. Let's do this. So it took 10, 80, and now this will update, hopefully. There, now you can see this is our executable, and it only took up that much space, but the original picture is not preserved at all because we replaced every bit in all of these bytes. But we could put that program in there, I don't know, 8 more times. So by spacing it out, now this is where it gets fun. Let's start with 100. Okay, definitely not even. 50. 20. 10 was, I mean, it should be. I mean, we could definitely do this mathematically, but I like just typing it in there. There you go. So 8 and 8. So we're using every single bit of each byte every 8 bytes. Or every 8 pixels. So let's update, and that's what that looks like. So these lines down the middle, that's our program. And now you can almost see a pattern to it. Like, is this data? Is this code? You know, are these the different segments? Hey, buddy, you de-noobing peeps? Kind of a little bit. So now, as easy as it would be to just do that, if we cut these in half and grow this by that, not enough space, so it's 10. And of course it's not linear. 5, 4. Yeah, what do you know? So we cut it in half, and it was 4 and 4, 8 and 8. Now if we open this, and you look at this, you can see it faintly, because we're changing half of them. But if we go down to 3 and probably 6, oh wait, we went down, so we have to go up. 8. I mean, God, we went down, so we have to go down. 3. Hey, look at that. 3 and 3 works, and 4 doesn't. So 3 and 3 is it. So this just happens to work out that, like, usually it's not that simple. But yeah, here you can see that we just have a dot down here. But now that we're only changing the 3 least significant bits, you know, there's the original, there's ours. There's the original, there's ours. There's the original, there's ours. You know, we could put that in there without a problem. And this is compression. You can create a compression algorithm. It is. Yes, it is a compression algorithm. Exactly. So from here, let's just decrypt that one more time, just for all the people that just came in. We want to decode, and let's do worked maybe 2, and this is SFIH. Now this is that tiny little bitmap. That's this right here. Fail, butcher, yeah, butcher. It says funeral home, but I've reduced it in either size or quality. Can we read that on the original? So here's the original, and you can almost make it out. If we zoom, yeah, still can't. So yeah, now worked 2, it worked maybe 2 is right here, and it still runs. So we pulled an entire executable out of there. Now the fun stuff. Let's get back to a bigger one. How big city? 1.42. Of course, this means that the bitmap has to be at least as big as your file to take up the entire thing. So you got to have some headroom. So let's go back to our good friend OK. OKB. That's 10. Jesus. OK big. 8. OK big 2. 19, Jesus. Let's do view details. Size. Now we want any OK pretty much, and we want somewhere around like 5. Probably do it. Do I not have one? I don't seem to have one. Well, we'll use OK big. So OK big is 8 megabytes, and this is I just resized the original, so we did lose some quality doing that. Yeah, so you just paste this in the email and away you go. So, I mean, the picture, you're changing the spacing, you're changing the number of bits you use. If nobody knew it was there, it wouldn't work at all. And I could put it in, I could build in like a password to where you have to type that in, and that would calculate some offset or something. Or you would have to know the spacings. But for now, I've had it put in the spacings. So here's the OK big. There's nothing in it. And let's see what happens if we try to decode something that doesn't have anything in it. OK big. Should be nothing dot txt. Complete. We got no file. It must went over to a different monitor. Oh, there it is. So how big is this? 0 bytes. And there's nothing in it. So, yeah. We could test for that and say nothing found, but whatever. So now let's go back to encode and let's go OK big. And then not FGLG crack me, but vr.rar. Now this is what I did all my testing with, or vbr.rar, sorry. And this is an old copy of VB Reformer. View that, VB Reformer 2017 Pro. And we're going to need to put that out here or give it exact, you can give it exact paths and it'll work just fine. How can you detect if the bit have been modified? That's the beauty of it. If you do it right, you can't. You have to know it's there or assume it's there and then look for it. You can't really detect it because it's just a picture. You're looking for a needle in a haystack where potentially it doesn't even exist, and if it does, there might only be one needle every 10 haystacks, and you got to put together 10,000 haystacks to find it. That's the beauty of it. So there's vbr.rar, and let's output, I'm just going to put OBH, and 33 is definitely not going to work, because now space needed 5527.88 available. That, let's shoot this up to, see, if we did 1, this still wouldn't work. Oh yeah, well, now this is going to take a little while because we're talking, can you put a key to, yes, definitely could put a key to decode it. I was thinking about that earlier. And essentially, instead of writing in make a single-use tool to search for RGB pixels. Well, the problem is, yeah, you could find the, so even if it's a tool or a file, I mean, you can find RGB pixels. They are RGB pixels, but you don't know how many bits of each pixel and how far apart the pixels are. So trying to decipher that without knowing the original values that were put in. For example, we put 3 least significant bits, and we're doing every single byte in the pixel. So this is going to affect red, green, and blue, and the 3 least significant bits. Now, if we open this, do you see a RAR in there? OBH. And there's OK big. There's OBH. There's OK big. There's OBH. And we didn't even optimize this. Look, we have so much room to go. We could go 2. No, we can't go 2. But if we go 4, we could go 2. Ah, look at that. So now we're doing the 4. This will probably be able to be spotted for the pixels. No. Short answer, no. Long answer, they aren't the same. So this number here says of each pixel, modify the lower word 4 bits of each pixel. This number says once you're done with that one, skip ahead 2, start over here. So these ones, don't even touch them. So when we have a number that says only change the last bit of this pixel and then skip ahead like 100, you would have to know these values. Like in the decode, let's look at the code. So here we're taking in these values and then we're saying split it up. We need to know what the length is. And okay, so here's our binary data. So we open a file, we convert it to binary data. So it's zeros and ones. Then we do message length is the length of all those zeros and ones. And then we need the binary of that length. And then we need our pixel density, which here is passed in pxs. And then we need our bits per, and that's passed in. And then right now, this is where you could put in the password or require that the decoder know these values. Of course, you could brute force these values. You could scan through all the possible values and see if anything useful came out. But then we could also require a password, like just cipher it with the password beforehand and then go for it. So right now I'm writing those to 2 just arbitrary locations so I can read them back later. And then I'm appending that length to our binary data. Then I calculate hey, is there enough space in the file that we are trying to do this in? And this is our required space. If not, then tell us about it. And then what it does here is where the magic happens. It is a simple. Of course it can't detect it. It's just a picture. Without knowing how to get the information out of the picture, nothing can get the information out of the picture. Does that make sense? I'm not compressing anything though, so like you could say that we are compressing the image with the data of our file, but yeah, I don't. What? No. See, that's where you're mistaken. This is just a picture. We can put this up on VirusTotal right now. Hash not found. Uploading. Nothing would be detected because I'm not modifying a header. I'm not appending any data. I'm changing. I'm interested in the decoder. How does it auto detect? It doesn't. And that's by looking at the encoder, you can see that. But this can teach beginners about steganography. Yes, because this isn't. So yeah, like you can't detect it because you have to know how to find it to detect it. So if you know how the encoder works, you know how the decoder works. So here's the encoding. It says from this point forward, we start at 0, grab that one. Convert it to binary and adjust it. The bits per byte do this many times. So if it's nil, then, or as long as it's not nil, continue. And go ahead and replace that with binary data of our first one, second, third, fourth, however many bits you're doing, up to 8, and then increase that and do that. And then outside of there it says replace in our original data at that point our new value, and then step by our pixel density, our pixel spacing, and then repeat until we are done with our binary data. So in the decode, your pixel density or your spacing, your pixel spacing, is just stored at this address in the file. It's 1 byte in the file, which is 8 bits, which gives you a value from 0 to 255. So 256 possibilities. And then bits per is stored there as well. Of course, this is limited to 1 to 8 because that's how many bits are in a byte, 8. And then you have your message bits, and then a U count, or you can, and your message bits, forgot. It writes that first, and it grabs that. This tells it how long the message is supposed to be. So it's going to grab, and this is 32 bits long, so it can be rather big. And then it will calculate that down. And then, yep, this is your message length. And then we start off our message with anything left over, because directly after that, yeah, so like I said, these are stored in the image just ahead of time, like from the encoding, but they don't have to be. They just are for, you know, ease of use, and they could be stored any other way too. Like you could require those to be typed in as arguments for added security. I mean, it wouldn't make it 100% secure, but anyways, and then it goes through, and where's my space? Oh, right. So anything after that message that was left over, because that, you know, odd happens, that starts off our message, or our what we're taking out of it, and then we just loop through it again, and we write that. So this is OBH. That's okay. And if we decode, and this was, let's just call it B.RAR. It's going to take just a little while. Back in my HBH days, I remember steg type encryption, but I never implemented it into any of my work, right? I never did either back when I played with it, and that's why now I'm like, you know, this is kind of fun, you know. I'm thinking that no matter what image I ever put out there, there's going to be something hidden in it. And you'll see that now we have a B.RAR over here that came out of this. This is still 8.65. This is still 8.65. So we took that. We took this. We encoded it into this without losing anything visually. And then we have a RAR. There's your setup. Everything still works. Lossless encoding. Without any. Can you spot a difference? I'm sure you can, because if you look closely, you'll see it. But it's definitely one of those satisfying things. It's just kind of fun to see. Now 3, can we go 3 and 1? Yeah, we did 3 and 1. Can we go? We can't go 2 and 1. Oh, maybe. Might be able to go 2 and 1. I'm gonna try it. Let's try 2 and 1. Aha! Look at that. So we're only changing the bottom 2 significant bits. We are doing it on every pixel. Let's see if we'll be able to spot it. Get the remote desktop program, put it in your hidden file. Send it to me and have it auto run, right? Problem with this is somebody has to find it. Like you can't, you couldn't be like, oh, they opened the image and they downloaded my file and ran it. It doesn't work like that. But here it is. Can you spot any difference between this one and this one? This one and this one. Let's zoom in. And let's open the other one. We'll zoom in on a couple spots here. Okay, big. So this kind of shows a little of everything, I think. Try to find that same location. See any difference? I sure don't. Maybe I'm biased. I mean, I forgot. I was trying to see a difference in the original, damn it. Oh, yeah. This is a little... You can see there's a white spot here. Oh, no, maybe it's just... yeah, I don't see any difference. Let's go down on the eye there. Drill it down. Yeah, I don't see it. And once again, we can decode that into b1.rar. And as soon as it's done, see, this goes through. It knows to look for these things because, well, actually the only way it knows is because I put the 2 bytes in there. If I didn't put those in there, you would have to specify those, and then it would try to look at its offset and whoop, try it. So there we go. We have B1, and it opens. So I am going to... How mean could that be? If I were to put the source inside a picture and then throw it on the web for you. But yeah, we're going to wrap this one up. We've been at it almost an hour just playing around. Feel free to download it. It is written in Ruby, so you'll need that to run it. Or if somebody wants to do Ruby to exe, sure. Or if somebody wants to rewrite it. Like, I just wrote it in Ruby because I started yesterday playing around in Ruby, and then I was like, you know, we can make this better. And then I spent all damn day playing with it. Yeah, neglect happened. Rockstars happened. I hope there's no ants in here. There's not. And one of these days, I'll probably rewrite it in assembly. That'll be fun. But first... Yes, Cat, the GA server, when you get that picked up, that's awesome. So, yeah. Alex, you're still here. Wow. Didn't know. Anyhow, let's move on to something else. I am going to put this in the tools section of the Discord. So if you want that, grab it. I have to find it. I even made it like dummy proof for anybody who happens to know a dummy. Delete those. Where did I put this? It's called fembed. Let's just go desktop. Invite me to Discord. The link is in the description. The invite link is right there. Click if you're on your phone. Tap, scroll down, click the down arrow. Very first line. Join the Discord. My bad, little Mao. Ooh, Mao. I'm just playing. But yeah, it's the if you bring up a good point. If you're new to the channel, you just tune it in because you saw the title and it was clickbait, and you're like, you're just stupid. Maybe you don't understand it. Maybe you don't want to learn. Maybe it is stupid because everything in life could be considered stupid. But to get back on a horse, the link for Discord is in the description. So if you want to play around with this stuff, we'll need Ruby installed to run. Or maybe port it, or maybe Ruby to exe. Is Ruby to exe still a thing? Let me edit that. Hide anything in a bitmap. There we go. If you put thought into the horse comment, you'll get it. I might have seen a horse once. I'm here to learn something I never knew. Hey, me too. Every day. Always looking to learn. And one thing that we all learned the other day was no matter what, never no, that's not it. never name your funeral home Butcher Funeral Home. Just don't do it. Like, that's the original file, and it's freaking fail. Butcher. You stab 'em, we bag 'em. Think back to what you said. If you put dummy. Oh, right. I might have seen a horse once. What is this? What is this? Oh, people are joining the party. Welcome aboard. Yeah, so that's there. Now, let's move on to Filmora. I think I installed it. I can't remember, but no, I didn't. I downloaded it. Did it go to my desktop? Damn it, where did I put it? Let's see here. Crack me. Let's see here. Request. Where the reverse requests. So it's called Filmora. There it is. So let's install this. And let's take a look. But first, a quick word from our sponsors. Kidding, I don't have any. But I'm going to take a quick break. For those of you that don't know, I quit smoking. It's been about 3 days since I've looked at you. Had a cigarette. So I'm not going to go take a break to have a cigarette, but I do want to stop this stream, rename it, and then start another one for the software that we're doing. Already installed your current. Yeah, remove it. I guess maybe I did install it. Yeah, quit smoking. I'm not counting days. I'm just saying, hey, it's been 3 days. I'm not like, ooh, tomorrow's day 4. I'm just like, yeah, vaping I do like, but it's different. Like, it's not like smoking. It's almost like hookah, if that makes sense. Yes, next. And so I'm going to let this install. It won't take that long, but I'm going to take a quick break. I'm going to hit end stream. I'm going to rename it, wait for it to complete, and I'll be back up. I'm probably going to go grab a bite to eat real quick. And yeah, but yeah, I need to give you that coil for the vape. Yeah, that's this one right here. Yeah, you gave me this. Thank you, buddy. Yeah, it tastes a little coily. Just a little. I never would have known that that's what that was unless you told me that. Join the User Experience Improvement Program. New launch. All right, I'm going to hit stop. I'll be right back with you guys. And inevitably, everyone will, not everyone, but many people will be like, where did it go? Did the stream go down? Gonna stop this stream. So it will be separate for Filmora. Be back soon. Okay, so I'll be back soon. Play ad.